In this video, I want to walk you through the approach that we took to develop the MedRec APIs. We started off using an agile methodology. So we started with a customer story, and that customer story ultimately would drive the design of our APIs. To capture the story, we used the developer cloud service, and the story we used to become a sprint within our agile methodology. In terms of the design, we were looking for a tool that would help us to very quickly validate and go from a documentation step of our APIs to validating that it was actually fit for purpose. So for that, we happened to use a capability called Apiary. Apiary allowed us to define or document our APIs in Swagger format. And a nice feature beyond the fact that we could collaborate around this as a team was the fact that it provides a mock server. So we can very quickly see what our API looks like in terms of real world, make a call and get a payload back. So it allows us to go from an idea to some sort of reality quickly. And that was very important to feed back to the customer to validate what it is that we had started to put together. Once we had completed our design, we went into our build phase. And for our build, we decided in terms of technology to use Node.js Express and MongoDB. We wanted to leverage again the developer cloud service, but this time for its Git repository capability. So we use that to share code artifacts as a team. One of the other nice features about it is when we build and went into our test cycle, we had the ability to automate our tests using the developer cloud service, and beyond that also to do deployments to our target platform. Let me talk a little bit more about our deployment and a deployment architecture. What we were really looking for, because we were taking a microservices based approach, was to have some sort of load balancer that would route requests to our API or our application API. Let's say application API, which, as I said before, was implemented on Node. With the whole idea was we wanted to be able to rapidly scale up, if the need required, other containers, being as this implementation here is using a Docker container, and we could spin up additional Docker containers, but more or less at the flick of a switch or hitting a plus or minus button on a web console. The load balancer then would expose target API endpoints, which would route through to our code implementation running on our Docker container. These application layers would talk through to our persistence tier. And for this, we happen to use MongoDB, and it was running in a virtual machine on Oracle Infrastructure as a Service. And for the template, we happen to use a Bitnami template for MongoDB and provision that onto the Oracle Cloud. The nice thing about this application tier here was we have a capability within the Oracle Cloud called Application Container Cloud Service, which does exactly what we're looking for. The last piece of the jigsaw puzzle was something called API Platform. And that would allow us to expose our APIs to an external audience and route through to this backend load balancer. But in between, we could attach policies such as an API key, without which no traffic will pass through the API platform, or a throttling policy to minimize the load on the backend service. I hope you found this valuable.